Prove that sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta equals to tan theta. We have to prove this. ठीक है, by left hand side sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta. Students, what is common in numerator? So sin theta is common. We will write here 1 minus this is sin cube theta. So sin theta is common. So we will write here 2 sin square theta over cos theta is common in denominator. So cos theta, this will be 2 cos square theta minus 1. Now we know sin square theta plus cos square theta equals to 1. The value of sin square theta 1 minus cos square theta. So we are putting the value of the sin square theta. In the place of the sin square theta, we are putting 1 minus cos square theta by using this identity. Now we will do multiply by minus 2 inside the bracket. We'll get here the sin theta 1 minus 2 1 ja 2 minus minus plus then 2 cos square theta. In denominator cos theta and this is 2 cos square theta minus 1. 1 minus 2, this is minus 1 and this is 2 cos square theta. In denominator cos theta, 2 cos square theta minus 1. These two terms are same. Now 2 cos square theta minus 1, 2 cos square theta minus 1 is cancelled out. We will get here sin theta upon cos theta. So sin theta upon cos theta, this is tan theta. This is your right hand side. Prove that sin a plus cos a whole square plus cos a plus sec a whole square is equals to 7 plus tan square a plus cot square a. Students, we are taking left hand side from here. Your left hand side is sin a plus cos a whole square plus cos a plus sec a whole square. Now we will apply here identity. You know very well a plus b whole square. This is a square plus b square plus 2ab. A plus b whole square. This is sin square a plus cosec square a plus 2 sin a into cosec a plus a plus b whole square. We are applying here to cos square a plus sec square a plus 2 cos a into sec a. Now we are rearranging all the terms. We are writing sin square a plus cos square a, then cosec square a, then this sec square a, 2 sec a into cosec a, then 2 cos a into sec a. We have rearranged all the terms. Now these identities we will apply in this question. Sin square a plus cos square a, this is 1. These all are formulae. 1 plus tan square a, this is sec square a. 1 plus cot square a, this is cosec square a, and sec a, this is 1 upon cos a, cosec a, this is 1 upon sin. So we are applying here sin square a plus cos square a, this is 1. In the place of this cosec square a, this is 1 plus cot square a, this is identity. 1 plus cot square a, cosec square a, we are applying in the place of cosec square a. This is 1 plus cot square a. In the place of this sec square a is 1 plus tan square a. So we are applying the value 1 plus tan square a plus 2 this sin a. Then in the place of this cosec, this is 1 upon sin plus this 2. Then cosec a. In the place of sec, this is 1 upon cosec. Cosec cancel out. Sin a cancel out. So you will get here 2 to 4, 1, 5, 6, 7. So this is 7 cot square a plus tan square a. And this is your right hand side. Prove that cosec a minus sin a in second bracket sec a minus cos a is equals to 1 upon tan a plus cot a. Students, we are solving here left hand side. So your left hand side is cosec a minus sin a in second bracket sec a minus cos a. We will convert all the trigonometric ratios in sin and cos. You know very well what is the value of cosec a. In the place of this cosec a, you will write 1 upon sin a minus sin a. In the place of sec a, we can write here 1 upon cos a minus cos a. We are taking 1 in the denominator, we are taking 1 in the denominator. These are two fractions, so we are taking LCM. LCM is the LCM of sin a and 1 is sin a. So this will be 1 1 ja 1 and sin square a, sin into sin. In second bracket cos a and 1. LCM of cos a and 1, this will be cos a. 1 1 ja 1 and cos a this is cos square a. Students, you know identity is sin square a plus cos square a equals to 1. So the value of sin square will be 1 minus cos square, and the value of this cos square will be 1 minus sin square. We can put sin square in the place of 1 minus cos square, and we can put cos square a in the place of 1 minus sin square. We are putting the value of this 1 minus sin square a. This is cos square a upon sin a. The value of 1 minus cos square a, this is sin square a. So we are putting here sin square a upon cos a. Sin a and sin a cancel out, cos a and cos a cancel out. So we will get here sin a into cos a. But we are not getting our right hand side. Now we will solve our right hand side also. So we have written here right hand side. So what's your right hand side? 1 upon tan a plus cot a. We are converting this tan and cot in the terms of sin and cos. The value of this tan a, this is sin a upon cos a. The value of this cot a, this is cos a upon sin a. We are taking LCM of these two fractions. The LCM of cos a and sin a, this will be cos a into sin a. Sin a into sin a, sin square a, cos a into cos a, cos square a. In numerator we have 1. The value of sin square a plus cos square a, we know very well, this is 1. So we are putting in the place of sin square a plus cos square a 1, and this is cos a into sin a. 1 upon fraction, so we are taking reciprocal of this fraction, so this is 1 into cos a into sin a. Okay, after multiplying we will get here cos a into sin a. You can see here your left hand side is sin a into cos a, and your right hand side is also sin a into cos a. So left hand side equals to right hand side. Prove that 1 plus tan square a upon 1 plus cot square a is equals to 1 minus tan a upon 1 minus cot a whole square equals to tan square a. Students, you can see here there are three parts, first, second and third. We have to show all the parts are equal. We are taking first part here. So by first part we are taking 1 plus tan square upon 1 plus cot square a. Students, what is the value of this 1 plus tan square a? We know very well this is identity. The value of 1 plus tan square a, this is sec square a. And the value of 1 plus cot square a, this is cosec square a. Now we are taking reciprocal of this sec square a. The reciprocal of sec square a will be 1 upon cos square a. The reciprocal of cosec square a, this is 1 sin square a. So we can write 1 upon sin square a in the place of cosec square a. Now we have fraction upon fraction. We can take reciprocal of this fraction. Numerator 1 upon cos square a, denominator sin square a upon 1. 1 into sin square a, this is sin square a, cos square a into 1 cos square a, sin upon cos, this is tan square a. So we can see here this is your third part, tan square a. So first part equals to third part. Now what will we do? We will take second part here. So second part, this is 1 minus tan a upon 1 plus 1 minus tan a upon 1 minus cot a whole square. We will convert this tan and cot in the terms of sin and cos. The value of this tan a, this is sin a upon cos. The value of cot a, this is cos a upon sin a. And we have whole square here, so we will take square of this part. We are taking 1 in the denominator, LCM of cos a and 1. This will be cos a and this will be cos a minus sin a. LCM of sin a and 1, this is sin a minus cos a. Now we have fraction upon fraction. But we will solve this part cos a minus sin a. We will change this sin a minus cos a. So we are taking minus sign common here. So we will write here sin a minus cos a upon cos a into, we are taking reciprocal of this part sin a minus cos a upon sin a. Reciprocal of this part sin a upon sin a minus cos a. This term is cancelled out by this term. Minus sin upon cos. Minus sin upon cos, this is tan a. Square of minus tan square a, this is tan square a. This is equals to third part. Now you can see here second equals to third. So first, second and third, all the parts are equal. Prove that cosec theta minus cot theta whole square is equals to 1 minus cos theta upon 1 plus cos theta. Students, we are taking this left hand side. So your left hand side is cosec theta minus cot theta whole square. We will convert all the ratios in sin and cos. We will convert this cosec in sin. The value of cosec theta is 1 upon sin theta. The value of cot theta, this is cos theta upon sin theta. We have written here cosec theta equals to 1 upon sin theta and cot theta equals to cos theta upon sin theta. Both the denominators are same, so LCM will be sin theta. In numerator we will write here 1 minus cos theta upon sin theta whole square. We are taking square of both the terms. 1 minus cos theta whole square upon sin square theta. Students, we know very well that sin square theta plus cos square theta, this is 1. The value of sin square theta, this will be 1 minus cos square theta. So we are putting the value of the sin square theta. Sin square theta, this is 1 minus cos square theta, and numerator 1 minus cos theta whole square. We can write it two times. We can write it 1 minus cos theta, 1 minus cos theta. Now we are applying here a formula. Students, you know a square minus b square. This is a minus b and a plus b. So the value of a square minus b square, this will be a minus b and a plus b. In numerator we have written 1 minus cos theta and 1 plus 1 minus cos theta. 1 minus cos theta, 1 minus cos theta is cancel out. So we will write here 1 minus cos theta upon 1 plus cos theta. This is your right hand side. Prove that cos A upon 1 plus sin A plus 1 plus sin A upon cos A is equals to 2 sec A. Students, we are taking this left hand side. So by left hand side, we are writing cos A upon 1 plus sin A plus 1 plus sin A upon cos A. There are two fractions, so we will take LCM 1 plus sin A into cos A. This will be the LCM. Cos A into cos A, cos square A, 1 plus sin A, 1 plus sin A, this is 1 plus sin A whole square. Now we will apply here identity A plus B whole square. A plus B whole square is A square plus B square plus 2AB. So we are applying here 1 square plus sin square A plus 2 into 1 into sin A. In the denominator 1 plus sin A into cos A. Now we are rearranging all the terms. So we are writing here sin square A plus cos square A. 1 square, this is 1 and this is 2 sin A. Students, you know formula sin square A plus cos square A is 1. So we are putting the value of the sin square A plus cos square A. Sin square A plus cos square A, this is 1 plus 2 sin A. In the denominator 1 plus sin A into cos A. 1 plus 1, this is 2 and this is 2 sin A. In the denominator 1 plus sin A into cos A. In numerator now 2 is common. 2 is common. In bracket we will write 1 plus sin A. In the denominator 1 plus sin A into cos A. These two terms are same. So this term is cancelled out by this term one time. This is 2 into 1 upon cos A. This is sec A. So this is 2 sec A our right hand side. Prove that 10 A upon 1 minus cot A plus cot A upon 1 minus tan A is equals to sec A plus tan A. So students, we will take here left hand side. What's your left hand side? Tan A upon 1 minus cot A plus cot A upon 1 minus tan A. We will break all the terms in sin and cos. We know formula tan A, this is sin A upon cos A, and cot A, this is cos A upon sin A. So we will put the value of tan A and cot A. In the place of tan, we will put sin A upon cos A. In the place of cot, we will put cos A upon sin A. In the place of cot, cos upon sin. In the place of tan, sin upon cos. Numerator will be same. In denominator, we will take LCM because there are two terms. So LCM of 1, you can write here 1, and LCM of 1 and sin A. This will be sin A. This will be sin A minus cos A plus LCM of this denominator, LCM of cos A and 1. Cos into 1, this is cos A. Cos A minus sin A. Now you have fraction upon fraction. So we will take reciprocal of this fraction. So you will write here sin A upon cos A into, you will take reciprocal. So sin A in numerator and sin A minus cos A in denominator plus cos A over sin A. You will take reciprocal of this fraction. So cos A in the numerator and cos A minus sin A in the denominator. Students, now what will you do? Now what is common? You can see here sin A minus cos A, and this is cos minus sin. So we have to make both the terms same. Means you have to write here cos sin A minus cos A in the place of cos minus sin. So what will we do? We will take minus sign common here. If you will take minus sign common here, so this sign will be negative. You can see here minus Sin square upon cos A and cos square upon sin A. And again we have two fractions here, sin square A upon cos A minus cos square A upon sin A. How will we solve this part? Because we have two fractions, so we have to take LCM, cos A and sin A. LCM of cos A and sin A will be cos A sin A. We will do multiply. Sin square A into sin A, this is sin cube A. Cos A into cos square A, this is cos cube A. And 1 minus sin 1 upon sin A minus cos A, we will write like this only. Students, you know identity of A cube minus B cube. So identity of A cube minus B cube is A minus B, A square plus B square plus AB. So we will use here this identity. This is your A, this is your B. A minus B means sin A minus cos A. In second bracket, sin square A plus cos square A plus sin A into cos A. In the denominator, cos A into sin A. Now these two terms are same. Sin A minus cos A, sin A minus cos A is cancelled out. The value of this part, sin square A plus cos square A, this is 1. This is the identity you know very well. Sin square A plus cos square A, this is 1 plus sin A into cos A. In the denominator, we will write here cos A into sin. Students, in numerator we have two terms, but in denominator we have only one term. So we will divide by this term in both the terms. You can write here 1 upon cos into sin A plus sin A into cos A over cos A into sin A. Means we are dividing these two terms individually. 1 upon cos A, this is sec A, and 1 upon sin, this is cos A plus this 1 we will write. So this is our right hand side. Hence proved. Prove that 1 plus sec A upon sec A is equals to sin square A upon 1 minus cos A. Students, we will solve here both the sides. First of all, we are taking here left hand side. What's our left hand side? 1 plus sec A upon sec A. We will convert this sec in cos. We know कि 1 plus, in the place of sec A we can write here 1 upon cos, because sec is reciprocal of cos. So in the place of this sec we will write here 1 upon cos A. In the denominator we are putting the value of this sec 1 upon cos A. Now we are taking 1 in the denominator, so LCM of cos A and 1, this will be cos A. Cos A into 1, this will be cos A, and 1 into 1, this will be 1. We will take reciprocal of this fraction. What is the reciprocal? Cos A upon 1. Now cos A cancel out. So we will get here 1 plus cos A. After solving this left hand side, we are getting here 1 plus cos A. But we are not getting this right hand side. Now we will solve this right hand side. Our right hand side is sin square A upon 1 minus cos A. Now in the place of this sin square A, we will put the value of sin square A. We have one identity, sin square A plus cos square A, this is 1. The value of this sin square A, the value of this sin square A, this will be 1 minus cos square A. So we are putting the value of this sin square A, this is 1 minus cos square A. Denominator will be same. Now we can write here 1 square minus cos square A square minus B square. So this will be A minus B and A plus B. In the denominator 1 minus cos A, 1 minus cos A, 1 minus cos A cancel out. So you get here 1 plus cos A. Correct? Now you can see here left hand side equals to right hand side. Let's prove. Prove that cos A minus sin A plus 1 upon cos A plus sin A minus 1 is equals to cosec A plus cot A. Using identity cosec square A is equals to 1 plus cot square A. Students, we have to use this identity to solve this part. We are taking left hand side of this numerical. By left hand side, we are writing this cos A minus sin A plus 1 upon cos A plus sin A minus 1. Dividing by sin A and cos A. Dividing by sin A in numerator and denominator. Why we are dividing by sin A in the numerator and denominator? Because we have to convert this cos in the terms of cot. We are dividing by sin A. So we can write here cos upon sin minus sin upon sin plus 1 upon sin. In the denominator, cos upon sin plus sine upon sine minus 1 upon sine. Students, you know very well cos upon sine is cot A. So in the place of cos upon sine we can write here cot A. This will be 1. Now plus 1 upon sine A. The reciprocal of sine A will be cos A. The value of cos A upon sine A, this is cot A, plus 1 minus 1 upon sine A is cos A. Now what will we do? We will rearrange all the terms. We will write cot A, then plus cos A minus 1. Cot A minus cos A plus 1. Now what will we do? We know identity cos A square A minus cot square A equals to 1. In the place of 1 we can write this value, and in the place of cos A square A minus cot square A we can put 1. Now we are putting cos A square A minus cot square A in the place of this 1. Students, you can see this 1 in the numerator. You will put this value of 1. In the place of 1 we are putting here cos A square A minus cot square A. And other terms we will write like this only, cot A plus cos A and minus in the place of 1 cos A square A minus cot square A over cot A minus cos A plus 1. Now we will use here one identity, A square minus B square. A square minus B square will be A minus B, A plus B. So we are putting the value of this cos A square A minus cot square A. This is cos A minus cot and cos A plus cot A. Students, what is common in these two terms? This is your first term, this is your second term. So cot A plus cos A, cot A plus cos A is common in both the terms. Cot A plus cos A is common. What will we write here in the place of cot A plus cos A? 1 minus, this term is common, so we will write only cos A minus cot A. Multiplying by minus inside the bracket. So we will get here 1, then minus cos A minus minus plus cot A over 1 minus cos A plus cot A. Actually we are rearranging this denominator, 1 then minus cos A and then plus cot A. Now these two terms are same, this term is cancelled out by this term. So what will we get here? Cot A plus cos A. This is your right hand side. Prove that under root 1 plus sin A upon 1 minus sin A is equals to sec A plus tan A. So students, we will take here left hand side. We are writing here by left hand side. We are taking under root 1 plus sin A upon 1 minus sin A. Actually, we have this denominator in square root. So what will we do here? We will take rationalization of the denominator. We have 1 minus sin A here, so we will take conjugate, means opposite sign of this sin A. So we will do multiply by 1 plus sin A, 1 plus sin A in the numerator and denominator both. Students, what will we do here? 1 plus sin A, 1 plus sin A, these two are same terms, so we can write here 1 plus sin A whole square. In the denominator, A minus B, A plus B. This will be A square minus B square. We have written here formula A plus B, A minus B, A square minus B square. 1 plus sin A, 1 minus sin A. This will be 1 square minus sin square A. Now we are using identity here, 1 minus sin square A. The value of 1 minus sin square A, this will be cos square A, because you know very well sin square A plus cos square A is equals to 1. So the value of this cos square A, this will be 1 minus sin square A. So we are using the value of this cos square A. Sorry, 1 minus sin square A. This is cos square A. Now what is the square root of 1 plus sin A whole square? The square root of 1 plus sin A whole square is 1 plus sin A. Square root of cos square A is cos A. We will divide these two terms by cos A. We can write here 1 upon cos A, means 1 upon cos A plus sin upon cos A. Now 1 upon cos A, this is sec A, and sin A upon cos A, this is tan A. You know very well 1 upon cos, this is sec, and sin upon cos, this is tan. This is your right hand side.